Alright, this video is for ionic bonds, and we're going to go over some of the key principles when it goes to ionic bonds. It's kind of hard to figure out what exactly you're struggling on with this one because it's kind of a varied topic here, unlike naming, which is pretty straightforward, or Lewis dots. So first thing to remember with ionic bonds is they are always between a metal and a nonmetal, meaning you have to be able to identify which ones are metals and which ones are the nonmetals. Nice thing is with your periodic table, we know that this is all the right side of the periodic table, and this is all the left, really, and middle. Both of that is where you find the metals, which you can read. When you have an ionic bond, if the bond has no charge, it is what's called electroneutral. Because, as far as electricity goes, it is neutrally charged, so we do not have to worry about that positive and or negative charge. So, awesome. The other thing we have to be able to do with ionic bonds is compare them to covalent bonds. With ionic bonds, we know ionic bonds have a high boiling point, as well as they have a high melting point, both of which are very high for ionic bonds. Covalent bonds are low on those. So comparing an ionic to a covalent, you're dealing with a high or low boiling point. The other thing is to remember what type of ions there are. Actually, I can go down here. Nonmetals, these ones tend to form your anions. These tend to be your negatively charged components of this bond. Your metals tend to form your cations. Those are your positively charged parts of the element. Again, this is what's actually forming this ionic bond, that positive and the negative charge, but that's what we're going for. With these bonds, their goal, as always, is to get to 8. That glorious octet, that is what they still want. There's no getting around it. So they want 8 in their outer shell. So they will become anions to get to 8. They will become cations to get to 8 to complete that octet rule. Their goal is always to get that 10. Or sorry, that 8, sorry. Chemical formulas of ionic bonds, they're always used. We're trying to say how many atoms. So when we're actually writing out an ionic bond and we're trying to write it out, so I'm going to use sodium chloride just like I used in my other video. Sodium chloride, we're saying we have 1 sodium and 1 chlorine inside of this ionic bond. If it was like iron 5 chloride, chloride 3, no, that is not a real compound, but it will serve my purposes. We are saying we have 5 irons and 3 chlorines. That does go into account when we're doing the polyatomic naming and naming in general, but as far as this is concerned, that's the main thing about ionic bonds. The nice thing is most of you understand these ionic bonds very well, and it's just a matter of reviewing this material and figuring out, okay, they're electroneutral. It's a metal and a non-metal point. Metal and a non-metal. You have a high boiling point, you have a high melting point, and everything is based around getting that octet. So hopefully that helps with anions and cations and within the ionic bonds.